Welcome, morning people. So this series of talks is really fun for me. I love seeing the builder, tool creator, plumber talks. People who had to like power through probably some hard stuff to get their stuff working. That's what I love to see. So I'm really excited for this talk. How Citi advanced their containment capabilities through automation. Want to thank our sponsor for this talk, ClearVector. ClearVector helps you detect, investigate, and stop threats at runtime in your AWS environment. A real-time identity-driven approach enables you to quickly figure out who did it and take action. Get started today with a free real-time risk assessment of your AWS environment. We'll do Q&A after the talk. Raise your hand and I'll come over. We'll also be looking in Slack, Twitter, YouTube comments, the usual. Please welcome Damien and Elvis. Thanks.
Thank you. Thank you all for joining us. Thanks you for setting your alarms to make this talk. Really appreciate it. We're really excited to be here to not only showcase some of our capabilities, but something that we're really proud of because it has been built completely in-house by Damien, our lead developer in this project. So we're really excited to showcase it to the industry here. Just a really quick poll. How many incident responders are in here? Okay, so good. So this will definitely resonate with you, and hopefully you can see some of these capabilities that you could potentially use in your day-to-day. So what are we going to talk about today? So we split this talk into 4 different sections. First, it's just a quick introduction on who we are. Secondly, I'm going to talk about the why. So, we create all these nice tools, but why do we create them? What's the use case? What's the reasoning for creating these kind of tools? And why do we need to use them? And then the next sections are the majority of the talk would definitely be about the what and the how. So what is the Cloud Containment Automation Framework, or CCAF for short? And then how is it used? And we'll do that through a few video demos that Damien would go over. And the why is really important. And the thing that we're going to do with the why is we're going to actually use a simplistic use case to kind of go over a realistic attack in a cloud environment and then how we contain those resources. So that will kind of build into the what and the how. So let's get started. My name is Elvis Veliz. I've been at Citibank for, it's going to be 11 years next Sunday, but who's counting? I've held multiple roles at Citibank. I started in offensive security, red teaming, pen testing, etc. And then late 2017, I transitioned to cloud security. I currently lead the cloud security operations at Citibank. And ever since I transitioned to cloud security, I've loved it there. The rest is history. I love the community. I love the collaboration that happens within this community. So I'm hoping to be within cloud security for more years to come. So I love it here. On a personal note, I love to travel. There's some pictures. I have 2 cats at home. Hopefully they're watching the live stream. And I am a sports fanatic. Any MLS fans here? 1, awesome. So I live in Miami. I've been a season ticket holder for Inter Miami FC since day 1. So yeah, now Messi, for those who've heard, is coming to Miami. So it's really good for me and my season ticket value as well. So I'm really pumped about that.
Awesome. Thank you guys so much for coming to our talk. So I'm Damien. Just a short bio about me somewhat. So the first thing is I'm a cloud security engineer at Citi, primarily focused on the development and the architecture of CCAF, or the Cloud Containment Automation Framework. I hold a couple of AWS and also GCP certifications, so I'm pretty much multi-cloud certified. Hold a bachelor's computer science and a master's in cybersecurity from UMGC. Just got that master's like a month ago. I am an AWS community builder, DevSecOps mentor and advocate. So if you guys are all about cloud security, DevSecOps, holler at me after this. And then just on a personal note, I am a father of 2 cats as well. So it's not necessarily intentional that we both have 2 cats, but it just kind of happened like that. So, and then on a personal note also, I love playing video games, love watching anime. And then if you guys are into cars, I'm into cars as well. That's my Subaru right there. And yeah, that's a little bit about me. So
awesome. So let's get started. So why do we need to build something like the Cloud Containment Automation Framework? What was the use case? And really the best way to do this is to illustrate it through a simple but semi-realistic attack scenario in a cloud environment. So let's set the stage. So Finatry, it's an obviously fictitious company, at least as of the last time I Googled their name. Hopefully that's still the case. And they're a fintech organization, and like many fintech organizations, being afraid of being left behind, they've hitched their wagon to the whole AI/ML circus. And yes, it is a circus at this point. So doing some research within AWS, they decide that SageMaker is a service that they could use for a POC to simplify and accelerate the ML workflow from data preparation, model training, all the way to data presentation. So they decide to use SageMaker to build a POC environment that we have here. So again, it has to be a simple environment because we have limited time, but this would hopefully help you understand what the need of the cloud containment framework is. So here on the slide, on the right side of the slide, you can see the architecture. You have the ML developer. There's the SageMaker notebook instance that they access, and they decide to take some shortcuts because they're enriching some data from RDS, so they save those credentials locally, as you can see on the top here. They're also using long-term credentials or API keys, as you can see on the bottom here. And then lastly, they have the SageMaker role that has some certain permissions here, and the typical ML data bucket for the model data for the training that they're using. So very simple architecture, and you could probably just spot a lot of security, or at least 3 security issues with this environment, or this POC environment. The first one being obviously long-term credentials. I know that there was talks yesterday about some of the secret management solutions that you could do you could use to kind of help you not use long-term credentials. Obviously, storing credentials in clear text for the SageMaker notebook instance is also not good. And then lastly, over permission on the SageMaker role, as you can see with all these star permissions. So that's kind of setting the stage for then what an attacker is going to do with this environment, or what an attack will look like in this environment. So let's move on. So what does an attack look like in an environment like this? And before we do this, we have to make one assumption. And that's really not a far-fetched assumption. That's something that we've seen of various publications on, right? API keys that get exposed. So in this particular scenario, the ML developer committed their API keys to a repo, and then the attacker was able to get them to steal those keys from that repo. Again, not a far-fetched assumption. This is something that happens every day. All the state of the cloud security reports have this as one of the top techniques. So let's progress the attack. So, excuse me. The initial breach took place, and then the attacker is performing some discovery actions after they're accessing the AWS account. By accessing the SageMaker notebook instance, they're doing some discovery. They discover the database credentials, and they're also performing some enumeration to figure out what permissions that role has. So then, moving along, the attacker, seeing the permissions that they have with the SageMaker role, launches an EC2 instance in the tenant VPC and the customer's VPC with a reverse shell to be able to get AC2, a command and control, out to their environment. So you can see some of the code here, the user data that was used in that EC2 instance to launch that shell, the reverse shell, back to the attacker. So just real quick on the legend, anything that's red are attacker actions, and then anything that's orange has been resources that have been compromised by the attacker. So this is important because those are the resources that we're going to want to contain as part of this containment actions. Moving along, that EC2 instance, and they have the database credentials. So what they do is they start gathering the database data from the RDS database with those credentials, and they start staging it so they could exfiltrate that data out to their environment. Which leads you to the last step of the attack, which is essentially the collection of data from both the ML data bucket and the RDS database, and then exfiltrating that data to the VPC endpoint out to the attacker-owned S3 bucket. Again, a lot of this has been discussed in other attacker techniques in terms of not going through the AWS, not going through the internet, going through the S3 AWS backplane and through the VPC endpoint. So those are attacker techniques that are known in the wild. So this here is the end-to-end attack flow in this environment. As you can see, there is plenty of compromised resources, the SageMaker role, the credentials, the EC2 instance, which was launched in the tenant account, as well as the database itself. So those are the resources that we're gonna, from an incident response perspective, want to contain, want to stop the attacker from getting access to. Now, this gives you a sense, and I know there's some folks back here from MITRE, so thanks for providing MITRE Attack for Cloud. And this shows us what the attack techniques are mapped to MITRE Attack for Cloud. So this gives us a common framework of a knowledge base of attacker techniques known in the wild that we use as part of this attack. Now, a quick aside, Citibank was a founding member of the MITRE Center for Threat Informed Defense, so we actually sponsored and participated in this in the creation of MITRE Attack for Cloud. So, so this is just one thing I wanted to mention, and this is what the. Can you guys hear me, by the way? Yeah. And this is something I wanted to mention here. A quick shameless plug before I move on to the response side of the equation. So I mentioned how this is a hypothetical attack, but it's actually a little bit more than that. We have a purple team function within Citibank where we actually stage these attacks in a controlled environment in a semi-blind manner. So that means that only certain people know that this attack is taking place. And the purpose is that we want to train our incident responders to respond to an attack. So, this actually happens in real life, and then we see that their people, processes, and technology works, because we could develop all this amazing tooling, but if it's not actually working in a real incident, then it's not really valuable. So this really this kind of exercise that we do really proves that value. And just kind of the shameless plug part of it is that we're working on a talk for this. Our team is putting together the process, the methodology, the tooling that we're using, and showing the community what we do and then what the results are from those exercises. So that's kind of the working title there, tabletop to APT. So look forward to that in a future conference. So let's move on to the actual response of this attack. So going through the NIST incident response lifecycle, what would a response to an attack like this look like? And for this, we have to make another assumption, right? And that assumption is that somewhere along the way, there had to have been a detective control that would have detected this attack and alerted our SOC to actually respond to this, right? So many of the attacker techniques, or many of the things that attackers do is try to impair defenses, try to disable CloudTrail logging. That happens a lot in attacks. So whether it works or not, there may be a detection for that. And that's the assumption that we're making here. So the attacker tried to disable CloudTrail logging, and that launched a detection to our SOC. So here on all the way to the left here, you can see that alert, and that's an actual alert from our environment for disabling CloudTrail logging. So that's something that the SOC would have received. And in reality, a lot of these actions would have resulted in alerts, either detective or auto-responsive alerts in our environment. As a matter of fact, we have a very mature controls engineering environment, controls engineering practice, where we have over 500 detective and auto-remediation guardrails in the cloud. Not specifically in AWS, but also in other cloud environments. So a lot of this would have been detected. And I guess shameless plug number 2, if you're interested, we do go over how we at Citi have developed all these detective and auto-remediation guardrails in that AWS reInvent 2021 talk. So for those that are interested, definitely look at that. So then, what would a typical response look like, or a typical response timeline look like? So this is a very simplistic timeline of kind of a response to an attack. So again, the initial compromise took place. There was some post-exploitation activities. And then at some point, a detection triggered. And that's what I referred to in the previous slide. So the SOC receives a detection for a particular attacker technique. Then on the blue here on the top, an investigation ensues. So the SOC receives that alert. They start doing some triaging. They start looking at the techniques that happen. And then meantime, in parallel, the attacker continues to do some post-exploitation activity, compromising more resources, etc., right? While all that is taking place, an investigation continues to take place. And then towards the end of the investigation, the blue teams talking to the business, they come up with a plan, they know what got compromised, and they decide to, their continuity of business, they decide to put it into place, and then decide that, these set of resources need to be contained. We have to stop the attacker from moving on into the environment. We have to stop, this IAM role. We have to stop the SageMaker Jupyter Notebook instance, etc. And that's where containment comes into play. So why, again, going back to the question of the why. So why do we need cloud containment framework? Well, in our scenario, in our examples, when this took place, when we performed these exercises, containment actions, as you can see here all the way to the right, took approximately 4 hours. So just for a set of resources, it took 4 hours for us in Citibank to contain these resources. So why was that? It's really 3 reasons why that was the case. The first reason is that containment was something that we were throwing over the fence. So what does that mean? So throwing over the fence in the sense that security teams didn't have the access to perform containment actions. These are highly privileged actions that needed to take place, and security teams didn't have access. So what happened is security teams put together runbooks, really long runbooks, really detailed runbooks that our cloud operations team then had to execute on. These are people that may not be security conscious or have security expertise. So they were following these very long runbooks in order to contain resources. I actually had a screenshot in a previous iteration of this slide of the runbooks, and it was zoomed in 25%. And you couldn't really see anything, so I took it out, but that's how long the runbooks are, which leads me to the next why, which is manual actions lead to errors, right? So if you have a really long runbook that a cloud operations person is following, they're gonna make a mistake, right? There might be roles that have similar naming conventions. When they put it in following the runbook, they might contain the incorrect role. They might skip a step in the runbook. So it's not blaming anyone, but when you have manual actions, especially to contain resources which are a long runbook, then you run into that situation. And then lastly, and probably the most obvious, is scalability, right? So we talked about a few resources to contain, but what happens if there's 50 instances that the attacker launches into a VPC, right? I don't expect someone to go go manually through the console and follow a runbook for 50 instances, right? That's just not scalable. So with these 3, hopefully that makes you understand kind of the why we need cloud containment automation framework. But now I'm going to pass it over to Damien to talk about the what and the how.
Okay, so the what exactly is what we're going to talk about is the automated cloud containment framework that I developed and lead. So the first thing is that in order for us to be able to, well, it's designed by Citi engineers, including myself. So it is basically an omnibus framework that it focuses on the containment and collection of several of the AWS services. So, the actions, containment and collection actions for each service will definitely vary because they're not the same. We support over 10 AWS services for both containment and collection purposes, and collection is more or less the forensic capabilities that this framework has. So you can see that the automated snapshot collection, which is a forensics capability that we do have, we support snapshot collection for RDS instances and clusters, EC2 instances, and also EBS volumes and EBS volumes that are also attached to those EC2 instances. So some of the key features of this framework is that the majority of the infrastructure, the core infrastructure of the framework, is provisioned using AWS CDK, or the Cloud Development Kit. We've also integrated or have like webhooks and plugins for their different services within Citi and different processes and tooling like Splunk and so on and so forth. We also have the ability to be able to support cross-account containment. So I'm going to talk a little bit about that in the next architecture diagram, because that's essentially how we have it deployed within our environment. And then the last thing is that just to kind of give, or I would say enhance the user experience for this framework, we have a CLI tool that allows them to be able to execute the containment actions from their local machines by just assuming the security containment role. So without further ado, I'm going to give you guys an example or an explanation of the architecture diagram. So in this particular case, let's say, for instance, we're attempting to contain something, right? The first thing that we need, or the incident responder is going to do, step one, is They're going to log into the AWS console, and from there, you'll expect them to have a list of roles that they would have access to, with one of them roles being the containment role, right? So from that point, they're going to figure out which step function they're going to execute, whether it be EC2 containment, S3 containment, so on and so forth. They're going to construct a payload for that containment step function. They're going to supply that, and then they're going to execute it, right? So from step 3, move to step 4, which is basically the execution of the step function. That payload is then going to be passed to its corresponding Lambda function, and that Lambda function will then have an execution role. That execution role will give that Lambda function the access to be able to assume the role, the cross-account role, that contains the access for it to be able to perform the collection and containment actions in the tenant account, right? So we have everything deployed in one single account, and then we have a tenant account with that role deployed into that allows it to be able to execute the containment actions on the resources in that tenant account. So once it's completed, all that information is going to be sent back upstream, and then that's where we're going to construct the payload, give all the names of the resources that were contained, including any new security groups that we created, et cetera, and pass that to the SNS topic. And then from there, who's ever subscribed to it, which will be most of the incident response and security stakeholders, they'll get a nice, pretty email that tells them what happened during the containment, the containment process. So this is an example of an email that's basically stating like S3 containment. So you can see that S3 containment was taken successfully on, this resource in this account, and et cetera, et cetera. And then it also gives them an execution ID of what happened, and so on and so forth. So we covered the architecture diagram. Now we'll just dive into the project structure and in which we've created everything and how it's designed from a core level. So right now our project is comprised of, I would say, 5 different modules. The first module will be the constructs module. So when we're deploying things within CDK, this construct is pretty much contains all of the customized functions and classes for us to be able to perform lookups on the ARNs and whatnot that we're going to use across various different other stacks that we have in our environment. So the next thing is that the core package pretty much contains the core CDK code that pretty much create the initial infrastructure that's going to be shared across various different other, I would say, CDK stacks. So you have those KMS keys for encryption. You have that SNS topic and that ARN. You also have the S3 bucket for deploying that contains the Lambda functions and also the CloudFormation templates and whatnot. And then you also have those cross account roles. And then the second thing is that we have the Lambdas portion. So since we follow least privilege methodology, we are deploying our Lambda functions, and then we also have corollary step functions, which is a package that basically contains the code for creating those step functions and also those subscription filters for Splunk ingestion and so on and so forth. And then the last thing is the dist folder, which pretty much contains that compiled list of CDK generated templates that we're going to use for deployment. So if we take a look right here at this picture, you'll see that that's pretty much like a list of all the YAML files that have been generated by CDK that we're going to use to be able to deploy all of our resources. That includes, like, you see RDS snapshot, you see the snapshot Lambda, and so on and so forth. So in a sense, the next thing is that we have the core, which is the Lambda function within itself. And this is the core code that pretty much contains like all of the business logic and also the core logic that we have. So in this particular case, the handler.py file for the Lambda that we have is pretty much like the point of inception, right? So when the step function has been executed, that Lambda function or that handler.py file pretty much grabs that payload and then decides which action in the step function needs to perform. So we're going to take RDS containment, for example, right? So in a sense, you see in the handle.py file, there's pretty much a snippet of the code that has the list of RDS containment actions. So in a sense, we want to contain all of the IAM roles that are associated with that RDS instance or cluster. So it's going to call that method here, right? Then it's going to move to the RDS containment actions file. And from there, you can see that we're pretty much passing that same event through it. And we're taking a snapshot of or not taking a snapshot, but we're assigning those variables or the stuff that's in a payload to a variable, and then basically calling in another class, initiating another class, and then calling another function, which is containing IAM roles again. But this class right here is just responsible for all of the business logic. Is basically a service controller, and then once it's finished, it'll basically go through and it'll move to the RDS containment.py file, which essentially contains all of the core logic that is responsible for making those Boto3 calls and interacting with the backend AWS internal APIs for us to be able to, in this case, modify the database instance and pretty much replace security groups or contain network traffic, et cetera, et cetera. So once that takes place, that information is then passed back upstream, and you can see that we're returning key information like the contained IAM roles and then passing that back up to the step function. So just an idea of what happens at the core level when Lambda is executed. So now what I'm going to do is show you guys the how, which is how we actually use CCAF within our environment. And I'm going to give you all a demo. So it's demo time. All right. So I'm going to come over here and I'm going to execute this. All right. So we're going to take, in this particular case, we're going to contain a SageMaker notebook instance. So this is the SageMaker notebook instance that has been spun up in our tenant account. So you can see the status is in service, and for security purposes, we cover all of our ARNs and stuff like that. But you can see that one of the key things that we want to contain with this SageMaker notebook instance is the IAM role ARN that's associated with it. So this is the IAM role that we have, which is an execution role that is tied to that SageMaker notebook instance. And when we scroll down, we'll see that it has a list of 4 permissions, with the most important one being, obviously SageMaker full access. So it has full access to do whatever it wants to that particular instance. And if they want to attach it to another one, of course, it'll have full access to that SageMaker notebook instance as well. So you definitely want to pay attention to this one because this role in itself will be contained. So at this point, we're logging into the security monitoring account, which is pretty much where we have the core infrastructure deployed. And when we're attempting to execute this SageMaker containment step function, there's a payload that we need to specify. The first thing we need is the target account ID. So obviously the account that the resource is contained into. We have the target notebook name. We'll need the target notebook region, and then a cert ID, which is purely internal, but every payload requires it and every step function requires it. So you can see in this step function, there are a total of 5 states. The validate parameter state is essentially checking to ensure that, of course, the incident responder has created the input and it is valid. The second thing it's going to do is stop the notebook instance from running. The third thing it's going to do is attach that containment policy, which is basically creating a deny all policy and associating it with that role. And then the last thing it's going to do is generate a nice pretty report for our incident responders. Validate parameters, generate report, and generate error report is pretty universal for all of our step functions that we have in play here. The only thing that's going to change is those particular actions that you did see. So when we come back to the tenant account, you can see that the status of that notebook instance is in fact stopping. And then if we go to the IAM role and we refresh it, you'll see that we have another permission, which is basically says deny all SageMaker, the name of the notebook instance. And you can see that it denies all SageMaker all SageMaker actions for that particular resource, which the ARN for that resource is blurred out. And then we have conditions to where, let's say, for instance, if we want to do something to that SageMaker notebook instance, we would need to be a different role or have to have privileged access. So these are a list of all the principal roles that we have for security. So we're moving on to containing an RDS cluster. So within that same tenant account, we have an RDS cluster that we would like to contain. So you can see that we have one writer instance, one regional instance, and both of them are in an available state. And both are in the same region. So what's going to happen is that we're going to click on into the RDS instance. Oh, and it's also associated with VPC. Forgot to mention that. So you can see that we have 2 of the endpoints that we have for a writer and reader instance. And then we also have an IAM role that's associated with that RDS cluster. All right. So when we look into that role, we'll see that this role has full access to the RDS cluster or instance, right? So all RDS permissions are on the table. But when we contain this role, you'll also see another deny all policy attached to this as well. And then what I want you guys to pay attention to is that because this RDS cluster is associated with the VPC, what's going to happen is that when we contain it, it's going to create a new security group and disassociate all the previous security groups with the RDS cluster and associate the security group with no ingress egress rules with that RDS cluster, right? So similar to SageMaker Notebook, SageMaker Containment, we can see that we need to supply into the target account ID. We also need to supply the cert ID. So with this, the target resource name, we also need to supply that, which is going to be the name of the RDS instance or cluster. And then we also supply that region. And then we need to specify whether or not it is an RDS cluster. So if it is, we'll pass in that Boolean value true. And if it's not, which means that it's an instance, we'll pass in that value false. So we're going to start the execution. It's in progress. So if we scroll down, we'll see that similar to how we had in SageMaker Notebook instance, we have the same validate parameters, generate report, and generate error report. So it has this choice state. Is it an RDS cluster? So obviously we pass in it is true. So it's going to say, okay, at that point, let's go ahead and let's contain that RDS cluster. So the first thing it's going to do is contain the RDS IAM roles that are associated with that cluster. So if there are multiple, it's going to contain them all. The next thing it's going to do is contain the network traffic. So by what that means is basically it's going to create a blank security group, remove all of the current security groups associated with the cluster or instance, and associate that security group with it, which means that no traffic in, no traffic out. The next thing it's going to do after that is going to stop the RDS cluster from running, and then it's going to generate a nice pretty report with all the details. So when we move back into the tenant account and we'll refresh this, you'll see, if I scroll to the top, you'll see it's stopping. And when an RDS cluster stops, there's no way for you to be able to manipulate it. It has to be stopped first. So the next thing is that since it was only one role associated with it, we'll see that we have a contain all, a deny all policy associated with it. So essentially the same thing, denies all RDS actions for that given cluster, unless of course and the only people that have access to it are the security roles that we have within our organization. And then once we pass this, we'll navigate on over to the VPC management console, a screen where we see those security groups. And we'll be able to see the security group that has been created for that RDS cluster. So you can see that we have a security group that pretty much says contain the name of the RDS cluster associated with the exact same VPC. And if we look at the inbound and outbound rules, no rules in, no rules out. So pretty much very stale, no network connectivity or traffic for it as well. So as RDS cluster containment within nutshell. And then we have a surprise, which is going to demo our forensic capability, which is going to be S3 object collection right after this. So S3 object collection, you can see that in that same tenant account, we have S3 bucket with a malicious script and also digital cloud leader receipt. So we want to be able to copy these into our forensics account, these objects into our forensics account. So if we go to the next tab, we'll see that we have another bucket with our forensics account named forensics objects 990. And this is where we should see those objects from our S3 bucket copied into this S3 bucket here and labeled with the name of the S3 bucket as well. So two different accounts. S3 object collection is a little bit tricky, but I'll cover it when we get to the security monitoring account where we execute that step function. So similar, same thing, target account ID and assert ID. The thing with the forensics part that changes is that we need to pass in that target bucket name that we want to collect. We also need to specify the forensics account name. And on the back end, this is basically us associating or mapping the forensics account name to the forensics account ID, and also the KMS key that we're going to use for encryption that's encrypted with that bucket. right? So that's going to have that information that we need to be able to run our decryption actions and encryption and so on and so forth, re-encrypt, et cetera, et cetera. And then we also have the forensics bucket name that we're going to pass in, which that's going to be able to, we'll pass that in and then execute our state machine. So, oh, the bucket's name is wrong, so he's correcting it. He meaning me. So let's start the execution. And so in this particular case, again, you see similar pattern. The only difference is that the 3 states that has changed is collect all objects, the choice statement, collect all objects, or collect a single object. So we have the ability to be able to collect all the objects within the S3 bucket, or just collect a single object. So in this case, since I didn't pass in an additional parameter, I'm basically collecting all the objects in that S3 bucket and shipping them on over into that forensics S3 bucket as well. And then once that's finished, I generate a report, send it to our incident responders with all of the objects that have been copied from that S3 bucket. So when we navigate back over, you can see that in our forensics account in our S3 bucket, we have the objects that we had from that other S3 bucket that we basically was compromised. So that's S3 object collection in a nutshell, and we're done with that. So now we're just going to conclude the presentation, right, and explain the benefits of CCAF and also future enhancements. So by using it for the Finatry breach, right, as you just saw, we reduced the amount of time for containing those resources from 4 hours to less than 15 minutes. The video in itself was about 10 minutes, and that's just me like explaining it and stuff like that. But if I was working at a different pace, it would be less than that. Some additional benefits that we have with this automation framework is that not only have we eliminated that possibility for human and user error, for executing those containment actions manually, like if we had to create those policies and associate them with the IAM roles and create them manually for like 100 IAM roles, that's going to be a problem, right? But it's also scalable. So we can do this for 100 IAM roles within a matter of minutes, just basically by just starting the execution, and the framework takes care of everything for us. And based on the way that we've developed it and architected the framework, it's very easy for us to extend it to other services in AWS for containing new services. And with that being stated, we do plan on expanding the capabilities of our framework to be able to contain those Lambda functions and also EKS clusters, EKS nodes, and pods. And with that being stated, that's all that I have. So thank you guys for listening. And yeah, that's it.
A wonderful presentation, Damien and Elvis. I have a couple of questions, maybe 2 for Damien and 1 for Elvis. Damien, is there a reason why you decoupled the containment action from the collection of forensic evidence? Because I'm thinking if you tied those two processes together with just isolate whatever resource and then collect the forensic evidence, it might reduce the timing loop, or maybe there's probably a good reason for that that you'd explain. And then the second thought that I had, which I've lost, I would ask the question that I have for Elvis. If one were stuck in a paradigm where the security team doesn't have firefighter access, that belongs to the ops team, do you have any thoughts in terms of philosophies about security teams potentially having access to be able to perform containment action? Yeah, those are the 2 questions.
Okay, I think your question was way more loaded.
Yeah, so I mean, so what happens there is in our production environment, everything is through pipelines. There's no manual access except for break glass, which is just for those particular cloud operations folks that have that break glass access. So that's kind of what we run into the issue with containment, right? Because if we want to do containment, then we need to perform those actions, which are only break glass actions. So the only way we could justify it in that environment that's highly sensitive is to automate it and to make sure that we don't run into situations where we have humans doing it. So that was kind of the need that we satisfy with the Cloud Containment Framework. So I think that I don't think we have ever wanted to say like let's have our security people access this environment production. I think we approached it in the way that okay, let's provide a service that performs this, that we don't have to access it manually, and then we could there's auditing, there's various tracking capabilities that we could see that this is that we're doing the right thing in production. So that's kind of the way we approached it.
And then on the question about decoupling containment and forensics, it's more or less an architectural decision that was made just to ensure that we're following the principle of least privilege. So we're isolating and separating the delegation of powers basically between containment and collection. That does not mean that we can't execute them at the same time or right after each other, but it was just more of a decision to ensure that we're actually kind of keeping things separation of powers, basically. Yeah. That's coming in the future. Like, yeah, coming to you in the next talk.
Great presentation, y'all. One question I had was, is there a mechanism for validation in the framework or like outside of it that y'all use? Like, how do you know if containment was successful? Do you just like look through the logs and make sure that things look good? Or is there anything else?
So we do check the logs, but when a containment capability happens, like for example, like if we create a policy and it's associated with the resource, when that email is sent out, we generate the report, we're attaching the resource that was created, like the ID and everything else. So when we finish or when we go to the validation phase manually, we can see that, we can connect the dots there. So that's pretty much like how we validate it.
Okay, thank you.
Excuse me. So one question coming in from Slack is, in order to have this power, this framework must run with some pretty powerful privileges. What do you do to protect the framework itself, or monitor protect the framework itself from compromise?
So that's a great question. So the containment role that we've deployed is pretty much protected by our own internal processes that require the incident responders to pretty much raise a ServiceNow ticket or something like that. And their management and leadership have to approve of them, and they have to document the reasons why they need access to this particular role to perform those containment actions. Not only that, but we also have a list of a very, very, very tough SCP system within our organization. So there is little to no room of error for us to be able to like execute or add new permissions. We have to basically go through an entire process to and a review board for us to be able to, let's say, like add new features, requests, and stuff like that. So the police is being policed, right? Yeah.
So this is no different than any other software that's developed within the bank, right? It goes through the same threat modeling processes. It goes through the same, pen testing, et cetera, right? So it has to meet that criteria in order to be released, right? So that's how we ensure that that it's secure as well.
Thanks.
Great presentation. I have a couple questions actually. So what gotchas do you have if somebody wants to build this internally? And it's totally okay if you say like wait until we open source it and just adopt what we put out. That's fine. That was my first question. My second, actually, I'll let you answer that because my second question is unrelated.
Okay. So wait until we open source it. I'm just kidding. I'm kidding. I'm all about sharing the knowledge that we built and everything like that. So some of the gotchas that I would say is really, there's so many. The big thing is, of course, within an organization, you're going to run into a lot of SCP issues. So you definitely want to make sure that you're actually on top of that and monitoring like what you have the power to do, and then really kind of going through the process of, if you don't have it, getting the power to be able to do what it is that you need to do to automate containment and collection. The second thing mostly is more of a code challenge or like an architectural challenge to anything. But one of my biggest things that I've kind of learned while I was doing it is that you really must pay attention to how you're joining your services, like your components in AWS. Like for example, like Step Functions and Lambda to IAM roles, stuff like that. It's very nuanced in a way. So always ensure that number one, your execution roles that you do create have the ability to be able to assume your cross account role or what have you, and that you're not blocked by overlaying SCPs and stuff like that. So it's mostly about just the level above you as a developer, as what permissions you have and how you can get access to them.
That makes sense. Thank you. Oh, did you have a response too?
No.
Okay. So my second question actually was about the purple team bit that you were talking about, which you don't have to give too much away since you're going to give a talk about this too. When you stood up like an environment, or actually that is my question. Did you stand up a separate account to, with all those resources to emulate an entire threat scenario, or was it a pre-existing account, I guess?
So we have dedicated accounts within a specific OUs for this kind of activity, what we call SOC IR hands-on exercises, which we perform quarterly. So we basically spin up an account in that OU environment, and then have, like Damien was mentioning, the SCP restrictions. We have a lot of preventative controls in place that would not allow us to perform a lot of this. So we have to kind of get rid of some of those preventative controls to spin this up and then perform the actions, because at the end of the day, we want to test our incident responders. So really the detection piece of it, how they respond to these incidents, how they contain the resources, is the tooling working. So it is a separate OU within our environment, within our organization that we do it in.
And I missed one thing I wanted to say. KMS sucks. So if you are trying to do anything forensics, like creating snapshots and stuff like that, you're going to have a hell of a time with KMS. So just pay close attention to the documentation. Pay very close attention to the documentation. That's it.
Thank you so much. Cool.